send the reference to that.
James Keele.
I'll write down.
Quiet, please.
He is just.
I may be able to give you a reference to him.
I'm a electrical engineer. I got a master's degree in electrical engineering from the University of Texas and subsequent education at SMU and Southern Methodist University. And I studied relativity under Dr. Wolfgang Rendler, who teaches or who taught at the University of Texas at Dallas. And so I have a little education in that area. I've always been interested in physics. And I realized that my stance in believing SRT, or special relativity theory, is not very popular here. So don't throw darts at me. Give my presentation.
Point at the computer.
Here's an outline of my presentation. I'm going to show analogies of the electric field of a charge to the gravity field assumed of a massive object. And the hypothesis in this is that that there is a gravity field. That's one of the assumptions. And because I'm using special relativity theory, that is based on four-dimension flat space. I think they call it the Minkowski space. Then I'm going to show an outline of the SRT formulation applied to the electric field and to the gravity field. Then I'm going to outline a computer program to calculate perihelion advances. I devised a computer program in Pascal and ran it, and to my surprise, it worked. And I'm going to show some uses of this approach to gravity, and then some possible cosmological implications. Now here's an analogy of the gravity field to the electric field of a charge. This here is the Newton gravity formula, and there is the Coulomb force, and you can see the terms are quite similar. And we define an electric field by this quantity here, so we can define a gravity field by this quantity. And then to get the forces, we can just add mass, multiply the gravity field by the mass to get the force of gravity. And similarly, we can get the force, Coulomb force, by multiplying the charge by the electric field. Now, I'm sure Lucas would have consternation right here when I describe a field originated at a point charge. I'm using a mathematical point to describe the electric field. Also, the electric field does not terminate at a sharp point. It goes out into infinity, where it terminates on another charge or goes off into space somewhere. Now, flux density or intensity of the fields is uniformly distributed for a stationary charge or mass and varies as 1 over r squared. Let's see. Now, I'm going over the basic postulates of special relativity. The first one, the relativity principle, and all inertial frames are totally equivalent for the performance of all physical laws. Now, most of us don't have any problem with that one, but we have, a lot of you have a lot of problem with this second postulate. That light travels rectilinearly with constant speed c in vacuum in every inertial frame. And that's where a lot of the MPA dissidents get off the bandwagon. Anyway, I'm staying on it. And the velocities are relative to a stationary observer, and a stationary observer can be like a stationary charge or a person or anything that the other inertial frame is moving relative to. Now, the Lorentz force law is the starting point for the full force SRT transformation. And in the textbooks, the relativists start with this Lorentz law. And you notice that, well, usually this applies to a charge like moving in a cathode ray tube where there's an electric field and a magnetic field. But in my analysis, I'm just going to start with this first term right here, the QE. Force is equal to Q times E. And then we'll see how E, the electric field, is transformed with the Lorentz transform. And I don't think I have to define these terms here. V is always the relative velocity. H is the magnetic field, and E is the electric field. It could be EG for gravity and EC for electric. Now the transformation, the results by omitting the extra magnetic field source of the Lorentz force is this term right here. You see we got gamma factors in here, and gamma is, as you know, 1 over square root of 1 minus b squared over c squared. And we got a sine theta there. Did I miss? I might have missed it. Yeah, I missed something here. going the wrong way. Okay, I guess now for the gravity field, it's the same as this transformation, except I add a gamma term right here for the mass, because the mass increases with velocity. And that's the difference between these two. Charges are invariant in transformation, masses are not. Now this is a pictorial 3D representation of the fields. The radial distance, like from the point here to the edge of the circle, represents the intensity of the field. And this is a cross-section. Try to visualize this as a solid. The circle is a sphere, and this is kind of an oval solid right here. This part right here represents the length contraction of the electric field. Notice that it's augmented in the perpendicular direction to the velocity of the particle. And also notice that it's reduced in intensity in the direction of the particle, and also in the aft direction. Now, the Biot-Savart law ignores this part right here in his equation right here. And that's due to the cross product term there. And because it goes to zero when you go down to the direction here. Now, what it turns out to be is that this shaded area here represents the magnetic field created by a moving charge. And probably a lot of you have trouble with that idea. But I was able to, using this technology, derive the old Ampere law. The old Ampere law shows that there's longitudinal repulsion in a current carrying wire. And Peter Granol demonstrated that by blowing up wires with heavy current. Let's see. Now I take that formula for the gravity field multiplied by M1, and I do a reduction on the complicated terms there. This theta here is the angle between the radial vector and the velocity vector. And I do a binomial theorem reduction by eliminating the high order terms to get this term here. So you might say that this is a new formula for gravity, with a slight modification of Newton's gravity law. Now we'll divide that into two different components, that law. One of them is the Newton force. You recognize it. It's multiplied that by that one term. And the SRT force is that second term, and it had its main components are v squared over c squared. And it's got that theta direction too associated with it. And your pure GR people, they won't admit that a planet is the gravity field is velocity dependent. So I devised a computer model to test this out. The SRT excess force was tested in a computer program to see if this force, in addition to the Newton gravity law, would produce the Mercury perihelion advance. Now, at the Mercury perihelion, or perigee, whatever you want to call it, the ratio of the SRT force, FSRT, to the Newton force, I call Fn, is calculated to be 3.86 times 10 to the minus 8. Now, that's what relativity does to the Newton force, which is hardly noticeable, you know. So the SRT force is very small compared to the Newton force. Therefore, as an engineer, I can approximate things. I can use the Newton force and a pure elliptical orbit to calculate the velocity of Mercury and the time between segments and so forth. The Newton force dominates and is used to calculate the main parameters of the elliptical orbit of Mercury: position, velocity, and time. And the elliptical orbit is broken in piecewise into 80 segments, and calculations are performed at each segment. And in this program I used 15 digits for the computation, significant digits. The SRT force produces a small acceleration on Mercury and a small displacement. And this acceleration is defined by F SRT over the mass of Mercury. And this acceleration is reduced to two components, one in the radial direction. That's one from Mercury toward the Sun, and then one perpendicular to that radial direction. Then these small, then you do double integration on the acceleration to get distance, and I don't know, this formula was in my freshman physics book, and I use that, and the distance at each segment is calculated as the acceleration at that point, times t squared over 2, and then you add the initial displacement. And you do that for the radial direction and the perpendicular direction. Now, at the end of computing over one loop, the two small accumulated perpendicular distances are combined. And then we need a R here. If you think of a circle, 2 pi R is equal to circumference, then the radius then is, let's see, the delta S of the circumference divided by R is equal to the angular displacement in radians. And a suitable R is obtained for the ellipse by averaging the lengths of the semi-major axis and the semi-minor axis. And R is equal to A major plus B major divided by 2. Now that's a straightforward way to calculate that without going through all the math that Roger pointed out. Then the computer model extends the angular displacement of one elliptical orbit of Mercury to the angular displacement of Mercury occurring in 100 Earth years. And the following table shows the computed results of the program for Mercury, Venus, and Earth. There it is. Now, the computed program for Mercury came out with 42.6 degrees. Arc seconds per 100 Earth years. And the GR calculated is 42.98, given a difference of minus 0.89 arc seconds per 100 years. And I just plugged in the values in this program for Venus and Earth, and the computed advance is 8.18 for Venus. The GR calculated is 8.62, the difference being minus 5.1%. And then for Earth, it has a slight elliptical orbit, 3.63 compared to 3.84, a difference of minus 5.5%.
There's effectively difference. It's 8.16 and 8.62, that is 0.51.
Oh, it's correction.
Subtraction mistake there.
Your decimal point is off on the difference.
Where?
8.18 and 8.62. On Venus.
On Venus. What's the difference between 8.16 and 8.62? It's not 5.1.
It's a percent.
Oh, it's a percent.
Sorry,
It's
my
a percent.
apologies. My apologies.
It's a percent. Sorry about that.
Now, these error differences amount to an average of minus 0.34 arc seconds per 100 Earth years for the computer model as compared to the GRT values. Now, I'm not saying that GRT is right or not, but so.
So we don't need general relativity, is that the conclusion?
Huh?
So the conclusion is we didn't need general relativity.
Well, I'll go on.
Not yet,
The
until I finish.
gravity laws for high relative velocities of mass, you know. This formula is good for velocities up to c. I'm sure somebody will disagree with that. But if the masses are receding from each other, then the sine theta term here is 0, and so you only are left with the gamma term in the denominator. So high velocity as well as large distances decreases the gravity force. Now the uses of new gravity law may explain why rockets launched vertically travel further than predicted by Newton's gravity law. Also, the weight of a vertically rotating disk, rotating in this direction, will be non-uniform. The sides here will be lighter, and the top and bottom will be heavier, and the sides, you see, will be lighter. And a horizontally spinning disk should weigh slightly more than the same disk spinning vertically. Now that's, we're talking about, 10 to the minus 8 type weight changes, very small. And so the gravity law also gives supports for the SRT derived electromagnetic laws and vice versa. And I derived in the previous paper the electromagnetism law from SRT. And it has possible cosmological implications. And here are some possible cosmological implications. Space is Minkowski flat, which would suggest that the universe is infinite. However, cosmologists who believe in GR recognize that our space is flat now. They made some tests in the past using the cosmic background radiation and determine whether it spread out or converges or is flat. And they say it's mainly flat, so it just might be slightly curved, At least that's what they say. And I've shown that gravity is velocity dependent. I knew a doctor that came out of Notre Dame in physics, and he told me he didn't believe that gravity was velocity dependent, and he liked the beauty of the equations of GR, I think. So anyway, I believe I've shown that, at least in our part of the universe. And so we can view the force of gravity as being due to mass and inertia, person to have use of concepts of geodesics and curved space. And GR might be used in the microcosmic region, and SR might be used in macrocosmic. Now, this is the end of my presentation, and so